Hello, am I audible? Am I audible?
Sir, you are audible. Yes, sir, you are audible.
Hello. Hello. Not like that. Am I audible? I'm not able to hear you, Mr. Vijay. Okay. Hello. Yeah, sorry. Sorry about that. Just give me a second. Let me share my screen. Is my screen visible? Yeah, sure. Okay, let's start. So we are ending in the last session, types of dynamic analysis. Here we can see different types of dynamic analysis. Like if you go into linear dynamic analysis, you can do natural frequency excitation, transient model dynamic analysis, harmonic loading, response spectrum analysis, and random loading. And if you go to nonlinear, you have transient implicit dynamic analysis. And other analysis types in ABAQUS are heat transfer. You can do acoustics like NVH problems. You can do mass diffusion. You can do steady-state transport, electromagnetic analysis for eddy current analysis, and magnetostatic analysis. Like multiphysics like thermocouple analysis or structural acoustic analysis, uh, linear piezoelectric analysis. These all can be done using ABAQUS standard. So before we go into so this is the basic ABAQUS GUI, how it looks, and okay, you can see various toolbars here, files for importing or exporting the model, starting with the new directory. I would request you to set up a directory before you start any analysis. That is, so that it will be easy for you to document what you're doing. Everything it will be generally in C10. I would like request you to create a folder. Set up a work directory. That's how you can do that. And here you have various toolbars. Here these are visualization toolbars. You can rotate, how to rotate a model, pan the view, zoom, auto fit. If you have assemblies, you can use these options to replace the, to view certain parts of the module. And here, as we spoke before, as we seen before, just give me a second. So, as we've seen before, these are the modules available in the ABAQUS. So we can start by one. These are very easy steps so that you will be able to do your perform your analysis perfectly. So it's very simple. If you go to the path, you can go to and then go to property, assembly, step. You need to follow all these steps one by one. When you go to each module, you will see corresponding to the modules all the features available on the module to your left on this side. And also you do have so on the left you can see the model tree. Okay, here you can see from here also you can access your model. First you will have the model and the parts as according to that, and then material you can calibrate, and after apply a section you can see the various sections in there. And then when you come and the profile of the section that you have applied, and when you come to assembly, once you create an instance, you can see how many instances you have created. Okay, and again you can hover over it, and you can find out what's the option there, steps. And if you right click, you can see the manager, and you can create or manage the feature. So when you go to steps, you can go to field output. You can create new field output. Okay. And then here you can see loads and the boundary condition. You can add the loads. So you the same if you go to the module loads, you can see here. From here you can apply the loads. This is the boundary condition. So this is what we covered previously, static analysis and dynamic analysis, and various types of analysis that can be performed with ABAQUS. So this is the main area that you're seeing is a viewport. The main area that you're seeing here, this is called the viewport. So with visualization, you can see the results. You can animate the results. Let's go to the new part. So in this workshop, we'll be doing 3 types of analysis. First, we will do a static analysis, and then we'll do a dynamic analysis, and then we'll do a natural frequency analysis. Okay. Would you like? Am I going too fast or too slow? Is it audible? You can just let me know. Hello. Yeah. So, do you guys have the access to the ABAQUS right at the moment? How many of you have access to that? Okay. So it's just a virtual lesson. So is this being recorded from your end? Okay. Okay. So there are different ways of accessing the model. So first, if you already have a CAD model, you can use an import option. You can import sketches, parts, assembly, or complete model. Okay. So let's go to the part model. And let's do a static analysis, basic static analysis. And I'm going to create a sketch. It's going to be 3D extrusion, and in this you can see you can write the name of the part. Like I'm going to create a beam. It's going to be a 3D beam. Okay, and it's going to be deformable. Here you can give the type of 3D which you want to generate, and then here you want to create. If you want to 2D, you can create shell, wire, and points. Okay, in 3D you have solid shells and wire and points. So in 3D, I'm going to do an extrusion. Okay, here you can give the size of your viewpoint and give it and continue. Okay, control. So in this part module, here you can see various features available. Like you can create points using a line option. You have creating a circle. Like this, you can create the circle and create radius. And similarly, how you use it is very similar to how you use a CAD code. Let's see, you can give the radius. And go back. So let's create a small beam. I'm taking the rectangle. Now, once it's done, I'm giving dimensions. 20. Once you're given the dimension, you can do escape. And it will ask you for the extrusion. So I'm going for the depth of 100 mm. You can see you have a solid block here. Once you come out of the sketch module, here you can see various options available here. You can do solid extrusion like we did this now, or you can create another part. Here you can give fillets. You can do small modifications in the geometry. If you have already geometry and you import it from doing a step file or IGS file, and you want to do small modifications, here are the features available to do the modifications. So we have a part now. Okay, now let's go to properties. In this property module, here you can see, here you can create a material and then edit the material database, and you can assign the sections. These all options are in the property module. So Abacus inherently does not have a unit system. So whatever the unit system that you're following, you have to follow a particular unit system for all the data points that you're giving. Okay. Abacus, if you go to units, Abacus uses no inherent unit system. Okay, so if you're giving an SI system, you have to follow. If you're giving meters, your force has to be in length. You have to follow a particular system like that. And if you're giving in your mass will be in tons. Similarly, if you're giving feet, all the remaining data should also be in particular imperial data. Okay. So now we have created a path. Now let's assign some material properties for that. So material, I will give you steel material. General properties. Here you can see various, when you click on general, you can see various properties available. So I'm going to give density. I'm going to use in so this will be 7.8 e⁻ -9. And once you go to mechanical, here you can see elastic material details like elastic details like Young's modulus and Poisson's ratio. And if you want to go to plasticity, you can do plastic details. You can do damage properties. Okay. And if you have if you want to add the mechanical thermocouple process, so you can have temperature details as well of the material. You can give conductivity and the Joule seed fraction. If you have an electric model that you're working on, like a circuit, here you can give the electric conductivity of the material that you're providing. Okay. And here you can click on elastic. So you'll get your Young's modulus. For steel, it is 3.1 e⁻5, and this is 0.3. Okay. And click on OK. So once you have created a material property, create a section. So what we have created is, this is a beam that we have created, and this is a solid, and this is homogeneous. Okay, continue. So you will see the dialog box showing the material that we have given. So if you have given multiple materials and if you have multiple parts, here you will see the detailed list of each material that you have given. Okay, and you can assign click on the part and you can assign the particular material for that part. Okay, and then click OK. Now let's assign the section. A beam and OK. See now, once you assign the section to the beam, it's changed the color. Okay, you can see now it's gone into green. Hopefully I'm clear till this point. Okay, so here similarly, let's create one more problem. Like, well, if you are creating a simple, if you're creating 2D planar, okay, if you're creating 2D points, 2D wire elements, okay, like this. I've given a small wire. So you can simplify your problem. You already have a problem, so you like a whole structure. You have a complete structure. You're not going to do the analysis. You try to simplify the model that you have. So by simplifying, you can use various methods. You can use 2D elements, 3D elements. Okay, I'm using a 2D element here. So similarly, you can give dimensions here. So this is 150. And then So that's how we create 2D elements. Now, if you already have a model that you want to open, you can just open. Normally your models will be saved in .cae file. So same beam that already I have created. Okay. So see, you can see the part. Once you import it, you can see where this in the part where the switches that have got. So now we go to property. You can see this is already having a. It's in the green color. So the property that we have assigned has been given to the material. Let's create part number. Like this, you can create shell part. I'm going to get a 3D part once again. Sorry. So this is a beam section that I've created again. You can see. Since you're not working with me, I'm just trying to create multiple tabs so that it will be able to understand clearly. Okay. So now we're doing property. We assign the section to okay. Create an instance on the top. It will ask if you want independent mesh or independent. Do you want the mesh to be part of the instance that you created, or do you want mesh to be independent? Here you have the option for that. Okay. Now assembly is done. We go to step. Create a step. Let's create a static. So here you have in the step you can create a various types of analysis according to the analysis that you are doing. You can create this. Then you can select the options from here. Now we are creating just a static, so I'm clicking on the static general. If you're doing dynamic indices or dynamic exclusive, depending upon what you're doing, you can select options from here. Okay, now I'm creating just a static step, so I'm clicking OK. Description, this is going to be just a static analysis. And here you can, if your problem is non-linear, then you can turn on this non-linear geometry option. And here you have increments. So for your base step, this is initial increment and minimum time step for the increment and the maximum number of increments that you want. Okay. And click on OK. So here you can see I have already created a step. From here also you can edit. You can turn on the geometry. If you forgot to create there, you can click on the geometry to turn on the non-linear geometry properties. Okay, again, or you can edit from here. So that's the step part. Now, see, in this is the interaction. Since this is on a single part and we do not have any contacts, we're going to skip. But if you're having a model, complete assembly, or if you have multiple parts where you want to do the interactions, here you can view the interaction. So here, this is the option. You can create different types of surface to surface, self-contact. Okay. So in surface, and you can edit them accordingly here. So these are the features available for creating a contacts. Now let's go to load. Let's apply small load. Okay. So we're going to apply a pressure load. Okay. This is going to be static. I'm going to name this as pressure. Okay. And you can create it as mechanical and continue. So you have to click on the surface where you're going to apply the pressure. So this is the area where I'm going to apply the pressure. So I'm clicking on the surface and done. So here you can give the magnitude. So I'm giving this 100 Newton. Okay. So you can see the pressure has been created. So instead of creating the pressure like this, if you want to create not on the entire area, or you want to, you might want to give pressure only on small area. That also you can do. How you can do that, I'll show you. So let me delete this one first. So here using model tree, you can see. You can select the details. So I'm going to delete this once again. Okay. So what I'm going to do is, I will go to my part, FINITE, partition. So from this, I'm going to create a partition on this. Okay. Done. Vertical and straight. Done. So click on this once again. Partition. Click on the edge. So this will come into your sketch again. Here you can do the partition. You can create a sketch. I'm going to do that. I will click escape and click it done. So like this, you can do the partition. Okay. Now let's go back to the load. So now deleted load. Now I will do one thing. Same. I will create a pressure. So the whole thing I'm doing pressure. Here you can see various types of load. If you want to give movement, you can give create edge and give movement, or shell load, different kinds of load, concentrated load. All can be found here. Now I'm going to create this surface. Okay. So similarly, I'm just going to reduce it. Maybe 15 Newton. A little bit, and so this is how my pressure is going to look like. So since I applied the load, I need to give a boundary condition as well. Here, see, for the static state that we have given, or you can give it as an initial condition also. Okay, so I'm going to symmetric and caster, continue. Similarly to previous problem. You can use this view, rotate. Now, select this surface and click it done. Here, I'm going to do encaster. I'm going to fix this in all the directions, all three. Okay. E1, U2, E3 represent your X, Y, and Z direction, and UR1 represents rotation in the same. Okay. So you have that and cast it forward. Now we have given the boundary condition as well. Here you can see the boundary condition in shade. Okay. These are the features available on your left side. And when you click on the right part, you can see you can manage. If you are to change, create another load case or anything, you can edit here. No, let's go to mesh. So it will automatically mesh. So this is not an assembly, this is single part. See, it's in green color. So first you need to seal. So I'll give this as a sealing is a size. What are the size of the element you're drawing? Okay. So I'm going to give it as a 4 and apply. So see, it will divide the part accordingly. And then you go to mesh and then click yes. So automatically it is generated the mesh. In the mesh option, you can go to element type, element region. So here you can see what kind of element you are using. This is a 3D stress element. Okay. This is a hex element. So here we have different types of elements that you can see. Tet elements, wedge elements, and linear, quadratic. You can change your elements accordingly. So whatever you can see on this side, the elements that are available on the standard will be here. And if you want to go to explicit analysis, then you have to change your element types. Okay. Since I'm not changing anything, I'll cancel it. Hope you're able to understand. Hello. Any doubts so far? Yeah. Anybody? Raise a hand. Or... Okay, then I'll continue. They're not doing anything. Let's go to the job. So what is job? In this module, this is where you have created drawn the condition and you created a step. So here you combine those. The job, and here you can give create a job. You can give a job a name. So this is just a start and continue. Okay. So here you can give description. Is it full analysis? If you want to restart, once if you give the restart option, you already have given the restart option, then you can use this restart option. So if you're doing an analysis, okay, and you have multiple load cases, okay, and so we want to see there is the first load case where you have seen the potential in the component, and then you have given some load case, and you seen the results of that. So now you want to before going further to another load case that you have in the list. So you want to change the amount of load. So using a restart option, you can change that load and do a restart. So now with same boundary condition, same thing, you can visualize the job will be again started again, and you can continue the job. So even or accidentally due to power shortage, if there is a if the ABAQUS is closed suddenly, by using a restart option, you can start the job again. Okay, and here in general, you can if you have normally there is a scratch directory. While doing analysis, all the files that will be written will be in the scratch directory. And once the analysis is done, this is where the folder it would be. You can change this accordingly. If you normally it's in the C drive, C temp, and it will use the data. If you have issue with the storage, you can specify this scratch directly separately, and you have memory. Okay. And parallelization. If you have multiple cores, if you have enough tokens, you can do multiple cores. Okay. You can change. You can use parallelization. If you have GPU accelerator, you can use the accelerator. Okay. These are the options available in the job. Now I click OK. So, and then now here you can see that once you click on the right side of job manager. Okay. So before doing any analysis, I would recommend to do a data check. What does data check do? It checks the model for the basic whatever steps we have done so far. It will check for the basic errors in that, like if you were given property or if you're given property like and you're given the density, you missed the properties of density, giving the density or ink modulus, or if you forgot to assign the property that you have given to the part, all these can be done during a data check, and it will throw an, if there is an issue, it will throw an error, and then you can check that and do the changes accordingly. So now let's go on. So now data check is completed. Now let's submit the job. So this seems to be concept already done in static. Just give me a second. I'll rename this one. So once I submitted the job, here you have an option to monitor the job, whatever you're doing in ANSYS. Here you can, if you use dynamic analysis, here you will be able to see increments and the steps. So it is completed. It's going on. So if there are any errors, the warning messages you can read from here. Errors, warning messages, and output files starting to write. And this is a DAT file where you find the details of the analysis. So here you can see the details of the job, the time taken, and there is a message file. If you have any errors, this is where, if we are doing a non-linear geometry problem or complex problem, this is where once the DAT file is written, it will start going into the message file. Here you will find the errors. So this is where you will see all the details of the job, and you can, to resolve your conversion problem, message file is very helpful. So now here you can see the analysis is completed, the status file. So all these files, since I have used the folder, this so I have given a work directory, right? So if you go to the work directory, so here you can see all the 4 files have been created. So there is a STA file. If you can edit, you can. If there is an issue, if you're given multiple processes, ABAQUS becomes, and you're not able to view it on that, you can come here and check the details of the same. So here, okay, and it will write an IMP file. So this is how the file looks like. First you have all the node details and the element details, and then here you have the material details given. Okay, the material details. You can manually change here also. The same will be updated in there. Okay, and here you can see the step that we are given. Static step. Okay, the increments that we are given, and the load that we have applied, and we selected, and the output request is pre-selected. So now let's go to results. Okay, so here this is a visualization. You can directly click from the job and monitor and go to visualization, or you can come to visualization. Here you can see here the results that you got. S is for stress and U is for displacement. Okay, this is a displacement and this is a stress. So here you can contour options, you can change, okay, what are the colors you would like. You can change spectrum, change the, accordingly how you would like to see the data. Okay. So you can see the contour options. As you can see the results here, these are your stress results. Okay, let me animate the same. So as we are applying the pressure here, you can see the stress is generating at the extent. And if you go to displacement, since we are applying load here, this is where your maximum displacement is. Okay, and here you can create plots. Okay, or to be, if you give a history output, you can, if you want to select, you want to see the part how the stress is flowing according to the time, You can create various data plots with the help of this. With the field output request that you have given, you can create the plots accordingly. Any doubts so far? Hello? Okay. So here, there are various options available here. So you can see. Here, I want to see how you can change it to feature edges. Here you can see how you want to render the model. Okay. These are the basic options. All the edges, all the edges applied. You can see the elements, all the elements in the element form. Now I don't want to see the mesh. You can hide the mesh by creating feature edge. You can click. So you can see that as a part. Okay. This is a general static analysis. Hope it is clear for everybody. Would you like me to recreate anything? Hello? Hello? Do anybody have any doubts so far? Okay. If you have any doubts, you can just leave in the chat box, so I will reply the same. Okay. No. So this is a normal static analysis that we have. Let's go for another again. So let's do a dynamic analysis. Now just think about, I'll give a sample example here. Okay. So think about a person sitting on the end of a beam and he has jumped off. So here there are two kinds of analysis that you can do. First, since until the point the person is sitting on the edge of the beam, it is a static load, right? So he's sitting and there is no change in the, it's not changing according to time, his weight net will not increase, so the weight is static load. So we'll do a static analysis and then think of it as he has from that point and he has jumped off. What would happen? It would become a dynamic event. Let's create a problem like that. So I already have created that and then I'll open. So if you go to, I have created similarly as I've shown you before, I have created a beam. Okay, using a part and a sketch, and I've given this properties of the steel. Here you can see general properties, density, then mechanical elastic properties. Okay. And then I've given density and elastic properties of the steel. So I've created a section. It is solid homogeneous section and steel part, and then that has been applied to the part. Okay. After giving the property, I have created an instance. This is an instance, and then I have gone to the step and created a step. This is where you can create a step. So whenever you find an option without any names on that, you just hover your mouse over there and you can see the description of that function. Okay. So this is create step. Since I'm already, and this is a step manager. Okay. So as I told you before, as long as the person or the weight is on end of the beam, it's a static load, and because of the static load, it's going to deflect. So After the deflection, when you remove the load suddenly, the beam starts to vibrate, right? So then it becomes a dynamic analysis. Okay. And the load. So I'll give you pressure. You can see the pressure load that I've given. Then created mesh. Similarly, like it's shown before. So first you need to see the part and then mesh the part. Okay. So same load which I have already given. So I will open the ODB file. So here you can see. So for the first step, it is a static step. So this does not have ODB result. Open the ODB file. So this resist, you can see 1 MVSR. Since this is a ductile material that I am using the 1 MVSR stress. If I animate the same, you can animate it. Okay. For the clarity, let us create the load conditions once again. Okay, I'm going to do delete the pressure. So pressure will be there. The boundary condition will be the same. So I'll go to the steps. And delete these steps and create the steps for better understanding. Okay. So create the first static step. Put the static general and then continue. I'm not changing any, so I will disable the static. So this is a static step that you can see here. Now I'll create another file which is dynamic. It's going to be dynamic implicit. Continue. So this is going to be a very small event. I give it as a fixed and I'll reduce the increment size to 0.01 and I'll give it as 1000. And go back to the low. Now we go to the low. I'll create a load static step. Continue. So what we are trying to create here. So here you can see I have created a load. The load is here. Its name is pressure. So what we in the first case, what we said, the person is there sitting on the edge of the beam. So the load will be there. But for the second case, the load is not going to be. The person is going to jump up. So there won't be any load on the beam. So I will remove, but there will be stresses induced because of that load, and we'll see the results accordingly. So now I will deactivate the load in the second case. Okay. Now, manage there. I go to job. I will create another job. Continue. Organization. I'll use multiple cores. Okay. And then submit it. Similarly, you can mount a job like previously. See, here you can see the difference in the static and the dynamic analysis. The static set is done in one increment, and dynamic analysis it's taking, and the number of increments have increased because of the dynamic analysis. So am I clear to everybody? I'm not getting any response. So hello?
Yes.
Yeah, I can continue. I'm just not getting any response from the students. So I'm just wondering if they are, is clear for them, or would you like me to go a bit slow?
Clear, sir.
Are you able to understand? Yeah. If
It is
you can
clear,
get
sir.
one or two responses, it will be good. Okay, thank you. Thank you very much. So I will have a small quiz by the end of this. So just to get an understanding on how much you're able to get from this. Just give me a section. Okay. While this is running, so it will take some time. So meanwhile, let us go to so as I've shown you previously, static and dynamic analysis. What are the differences? Okay. So while the run is going on, let's refresh our memory once again. So in ABAQUS, as I shown you, this is a model tree. Okay. This has all the information that you need apart from the module. Here in the model tree, you can look at all the details that are available, like part material that you created. You can edit from them. Okay. Different features. Once you click on that, you will find all the features available in that module. You can have a description. There will be a description of what the features are available. Okay. And similarly, the navigation. 3 features. You can navigate to various modules. If you can go back from part to step. If you have multiple parts, navigate. It will be easy for you to navigate between the various parts. You can have the query. Okay. Once you can see the plus sign here. So here, once you click, you will see the options available in there. What are the features available here? Like for the assembly, the multiple instances created. Okay. So as I told you before, all the toolbars are dockable, so you can move along the toolbars, whichever place you would like to, you can customize it according to your style, and you can give the inputs like while using toolbar, you can customize various keyboards for the shortcuts. You can create for the zooming out, or if you want to print or save the model, you can create various options for that. So as I told you, this is a view manipulation toolbar. So here you can rotate, zoom, pan. Okay, now the job is completed. Let's check the results. Okay. So so you can see the stresses generated in the bar. So we have to find. So features, features offline. Okay. Just give me a second. So you can go to results, you can step. So I will go to static step and apply. And okay. So this is the static step. So once the load is applied, this is how your beam is going to behave. So now let's go to the second frame. Perform static. And now I go to dynamic, apply. Okay. So this is how I can model a dynamic analysis and static analysis together. Okay. You can see from here you can plot stress results, strain results. Okay. Displacement. So now we see the static and dynamic analysis. How to do the same. We have to create a dynamic intersect model here. Let's continue and let's talk about natural frequencies. Okay. I'm going to change it. Okay. So what is a model analysis? Model analysis is used to extract the natural frequencies of a model. So what is the effect of natural frequency? Can anybody tell me what are natural frequencies? And what is the effect of natural frequency? Hello? Anyway, you can just give me an answer. You can send a message in the chat. Hello? Yeah, anybody can speak or just give me a chat for natural frequencies if you have any. Okay, so vibration without any load. So everybody has a vibrates at a particular frequency range. Okay, every body will vibrate at it has an inherent frequency in a vibration. So what happens is natural frequencies are the frequencies of a body without any external load. So the body is vibrating without any. What is the effect of natural frequencies? What happens is when you apply a load, And if the frequencies are getting closer to your natural frequency, what happens is the amplitude increases. What happens when the amplitude increases? The effect of that would be it will. What happens when the amplitude increases? Any idea? Okay. So why are we doing model analysis? Model analysis is to get the natural frequencies. So as we were speaking, when we apply a load or any frequency closer to the natural frequency, what happens is the amplitude increases and the model starts to vibrate more, and it will cause a failure in the part. Okay. So that's why we want to find out the natural frequencies. Try the natural frequency. Let us see a small. Think of a small structure, and let's create a small. And we'll create a beam section, and then we'll study the natural modes of that. So, okay. Let me go to the path. Sketch. Create. Continue. So think of a pillar array. When you're going into building, starting, there's a structure like this. Okay. I'm sorry, just give me a second. Part done. Sorry about that. Just give me a second. I'm going to get 2D and it will be Y section. Sorry. So think of this as a structure. Okay. Now, sorry, just get stuck here. Let me open one that I already. Okay. So this is the structure that is already there, and I have assigned a property. So this has a steel properties similar to before. The steel structure. Let us assume this is a steel structure. It has a given density and a given elastic properties. And I'm going to summary property, and when I give section, okay, here is a beam section. I can create a section, give a section. So since this is a wide, I have to give a section to that. So create it as a beam section. Continue. So here you can change the profile. So you want to give it as a box. If you want to give it as a circular section, I will like to give it as a rectangular section. Okay, continue. So here you can give for each this, it will be applied. So file, click OK. So profile 2 and OK. And you have to select the, you can see it has changed. And you have to give the orientation for the beam. Select the beam, hold control done. So you can see it has been oriented. I am not going to change anything. I am going to leave it as basic orientation. Okay. So, this property has been given. Similarly, to assemble, and we have to create an instance. Okay, this is already being created. So now let's go to the step. Okay. For the step, previously we had given a general static step. Now we are going to give a frequency analysis. We are going to do frequency analysis. So we are going to change it to linear perturbation. So in linear perturbation, we'll go to frequency. Okay, and create. So that's how I created a model analysis for that. So if you go to here, edit. So for doing model analysis, there are different solvers available: Lancos, Subsphere, and ANSYS. So since this is natural frequency and basic analysis, you can use the Lancos method. And I'm requesting only the first basic 6 modes, first rigid body modes. So what are the rigid body modes? Rigid body modes are the natural modes of the part of the body that you're having. So it will give first 6 modes in the direction. Okay. Next, we go to the load. Since there is no load, I created a boundary condition. It is in caster. So similarly to before, I selected these 2 points and created the boundary condition. So this is standing on the earth. So okay. After creating the beam, you can see it here. If I go to part of mesh and then view and then go to options, view option, I'm sorry. So similarly, as we followed the previous steps, after creating load, since there is going to be no load, and we're just creating the boundary condition, and we're going further. Okay, and submitted the job. Okay, let's see the results for the same. So just give me a second. Here you can see render beam profile apply. This was a beam profile that we are given. So similarly, even in mesh also you can do the same. Okay, now let's go to visualization and see the modes. If you do the animation, so displacement, and so this is second mode, third mode, fourth mode, fifth mode, and sixth mode. You can see. So bending, twisting, torsion mode. And whatever the displacement that you're seeing here, this is only for graphical representation. So whatever the displacement values that you get during the extraction of the natural frequency, these won't be of any use, the magnitude of the displacement that you're getting. Okay? So this is only to represent a contour and they will be of not much help. So you can see different mode shapes from this beam section. Okay, so we have covered all the three parts. We have done a static analysis, we have done a dynamic analysis, and now we are doing a frequency analysis. Okay, so any questions so far? Hello? Is there anything else you would like me to demonstrate at this point of time? Or you can just write a message in the chat box if you want to see something. So how can you apply varying loads at different times? So that we can do by, you have to give, if you go to loads and tools, and here you have amplitude option. Here you can create an amplitude, okay, table, and you can create the table of how your load is going to vary along with the time, okay. You can create the various values here. Perfectly, continue, and you can give the time, frequency, and the amplitude of your load, okay. And you can call the same in your loads. Hope I'm clear with that. So this is all from me. If you have any more queries, please do let me know. Just give it a second. So element quality check, how to do meshing convergence. I do not understand what do you mean by meshing convergence study. So meshing convergence study, so what I'm trying to understand is you want to see with different element types how the model behaves, right? Is that what you're trying to ask? So if you go to mesh and here, just give a second. So here you can verify your mesh, okay? Just give a second. Let me import the another model so it will be a bit more clear to you. So here you have verify mesh option. So select the region, part instance or elements, or you can create the set, or you can create the power instance. Done. So here you can see you can view aspect ratio analysis, whatever the checks you would like to do. Okay, geometry division or Jacobian. Okay, so you can give all the element quality check here. Okay, see, you can give the size. This is where you can do the element quality check. Aspect ratio, Jacobian, warpage, These are the details that you can give. So depending upon the chord angle that you give, so you can select the same. Okay. Maximum chord angle, since this is only hex mesh, so here you can give maximum and minimum chord angle. Okay, and then check the errors. If you have any poor elements, it will be highlighted. Okay. Any more queries? So hope you are able to understand, and just let me ask a few questions if you believe. And okay, so just to understand, are you able to understand what is? Just give me if you can drop in chat box. So what is static analysis? What is dynamic analysis? Just write sentence if you just think what we are doing. So while talking about ABAQUS, I told you one important thing that anybody tell me regarding the units. Does ABAQUS has any units in that? Nice. ABAQUS, good. ABAQUS does not have a inbuilt inherent unit system. It will take whatever the units that you're giving, and you have to make sure that whatever the units that you're giving are in proper order. If you're giving in SI units, all of them should be in SI. Even in SI units, if you're giving in meters, all the data should be in meters, and accordingly to that, or mm, or if you're giving imperial system, all your data should be in imperial system. Okay. So let me do one thing. Just give me a second. So I would like to end it here. So if you have any queries, just let me know. I'm available here. So if you can have a talk. Any queries regarding static analysis or dynamic analysis or natural frequencies?
Sir, are you able to hear me, sir?
Yes, yes.
Sir, I have a query regarding static analysis, and of course, they apply to dynamic analysis also. The point is that can we vary the properties of materials from one position to another position?
See, that will be becoming an, you're saying there will be material non-linearity then. So once you're giving some different, you asking would you like to change from one step to another step when you're going, you can change.
No, I'm not asking like that, sir. Even within say material, say for example, you have taken a beam. So at the bottom there is one property. At the when you reach the top, there may be another property.
Yes, that will come under material non-linearity. So normally there will be three types of non-linearity.
You can think that as a material non-linearity.
Yeah, that will be a material non-linearity. That will become a non-linear problem. So accordingly, you have to give the details, non-linear material details.
You mean to tell that we have to give an equation or some?
No, you don't have to give an equation. Normally, if we have material data, normally what we have is, so if you go into material non-linearity properties, so here general normal we give density, and if you go to mechanical elasticity. So what normal static behavior, what is non-linearity? When does the non-linearity come into picture? So when the property goes beyond, when the material behaves beyond the Hooke's law. So of the Hooke's law, after the yield point, okay. When the material reaches, then stress in the material reaches the yield point, it goes beyond the yield point, it becomes a non-linear. There we will give the plasticity. It will go into plasticity. There you have to give the plastic properties of the material.
That is okay, sir. What I intend to tell that, see, what you are telling is that during the deformation that is taking place, from position, from time to time, or with the amount of deformation, the material behavior is changing. That is, of course, non-linear material behavior. That's true. But what I'm asking is that whenever I need to have a property of the material that varies from position to position, even within the elastic limit.
From position to position in the elastic limit. Okay.
Within the elastic limit itself. Say, I may have a mixing of a material. I have one composition at the top, another composition at some other place.
So then you have to go. You're saying as composites.
Yeah.
Yeah, then
Of course, it cannot be laminar composite.
Yeah, laminar composite.
It cannot be laminate.
Yeah,
it cannot be laminate.
It may not be laminate. We can give it as a solid also. So then you can create a solid, composite solid. Okay.
Okay, but then you mean that we'll have to make a partition and then we have to give the property?
Yes, we have to give partition and give the property.
And of course, when we give the partition, so does the partition mean that it is glued or simply it is? I don't know how to explain.
It is glued. It is glued. It is glued.
I have to think that it is glued.
Yes.
Okay, I have to check.
What are the effects you are saying? The moment even as the property changes with respect to even the elastic layer, the properties will not be, the material properties will not be changing drastically, that it will have complete effect. Okay.
Okay. Let me see. Thank you.
Yeah, sure. So just give me a second. And, let me give you. I'm pasting a feedback form in the chat window. And fill the same. It will be very helpful for me. So I'll send a feedback form in the chat window. You can just fill the same. It will be very helpful for me. So I'm going to end the session as I'm not getting any more queries here. So, Mr. Vijay. So you can contact. I think you have my number, so we can. If you have any further queries, you can just get in touch with me, and I'll be very helpful. Okay, help you with that. Yeah, sure. You can send me the feedback form. It will be very helpful for me. Yeah? Thank you.
Sir, can you repeat